This video which I actually talk about how to translate any transfer function, okay, into magnitude and phase angle, okay. And then after which what we're gonna do is actually to plot out the table, okay. So you give me a while. So I have my frequency, okay, this is frequency. I have my magnitude and I have my phase angle, okay. So if this set we can actually find, okay. So this is typically when you plot when it is 0 first, okay. So when omega is 0, okay, this whole thing becomes 0. So 1 divided by, this is 0, right? So 1 divided by 0 is actually equals to infinity, okay. So when omega is 0, the magnitude is infinity. And then for the phase angles, um 10 10 times 0 is actually what? Is 0, right? So tangent inverse tangent 0 is actually 0, right? And then minus 180 degrees minus 2 tangent inverse, which is 0 also. So this whole thing becomes 0. So you have negative 180 degrees. So in other words, this is 180 degrees. The next plot we need to plot is actually the so this is infinity. Is actually to plot for when the frequency is infinity. Okay, so in this case, if it's infinity, this is actually infinity square. Okay, it's because infinity compared to 1 is negligible, and then infinity square, 1 plus infinity square. So as you can see, the infinity of this denominator is, the order is much larger than this. So therefore, 1 divided by infinity, okay, infinity is a very large number, right? So 1 divided by a very large number equals to what? 0, right? So therefore this is 0. And then for infinity in this case, inverse tangent infinity is actually 90 degrees minus 180 degrees minus away infinity, okay, 2 times 90 degrees. So in this case we will have equals to minus 270 degrees, right? So this is just a simple plot for a how do I say it, for 0 and infinity, okay. And if you were to compare it to the thing, okay, if the frequency is 0, okay, let's take a look. Okay, sorry, I think I need to zoom in. The graph is way too big. So to zoom in, yeah, it still cannot. Hold on a while. Okay, never mind. I can't actually show you the points because the values is too large. Okay, so it cannot show me anything. As you can see, is if the omega is equal to 0, the magnitude is infinity, and it is negative 180 degrees. So how is it going on? Okay. Before I continue, okay, I realized something. Okay, if you were to look closely, okay, this is actually the graph for our omega frequency. Previously, I say that we are coming in. Let's say this is a graph, right? We're actually coming in from this direction, right? And then it ends at the 270 degrees. And then now we are coming from here. Okay? It's weird, right? However, if you were to take a look in a more closer view, as you can see, the nyquist plot is actually quite interesting. When it goes all the way near, okay, it's pretty, as you can see, it's coming in from the 270 degrees. So if you were to zoom out again, so it goes, so it's like go all the way, and then it comes back here, like that. Okay, so let's say, for another example, when it comes from infinity, and then after it comes back here, and then it comes like that. So this is the thing that I want to show you. And because when I plot my graph, right, I feel weird because when I sub in when it is omega is equals to 0, right, my magnitude is actually infinity, okay, which is minus 180 degrees. So in fact now in the case it is true lah, because if my frequency is 0, okay, which is at this line, and it is my minus 180 degrees, okay, it should be, so the root locus should be starting from, so imagine I have a real axis and an imaginary axis. Okay, imagine this is like infinity, okay, at frequency is equals to 0, which is, because frequency is equals to 0 over here, and then at here is frequency equals to 1, right, and then maybe some value like, and then as you increase the frequencies, you're increasing the into the imaginary axis, right. So when imaginary, okay, is equals to, I think you get what I mean lah. So at this point frequency equals to 0 lah, okay, and then because it is negative 180 degrees, the phase angle, okay, which is shown over here. Where am I? On my table, sorry. We have calculated negative 180 degrees. You have, where are we? So therefore, our magnitude should be over here, this point. Okay, so if you were to plot, okay, plot this plot. This is 0, omega, I mean infinity, and then minus 180 degrees. So in other words, so if I have a table like this, right, 0, infinity, so when my frequency is 0, omega equals to 0 over here, and then if it's the phase angle, it's minus 180 degrees, and then the magnitude itself is all the way at the infinity line over here. So this is what it means lah. Okay. So this is at this is the point. And then at infinity, okay, when my frequency is all the way out there, okay, let's say this is infinity, the magnitude is actually at 0, which is at this point over here, and then minus 270 degrees. So it's coming somewhat, you know that it's coming from here, right? So if it's at 1, okay, I actually plot it at 1. Okay, let's say if you plot at 1, so as frequency, if frequency is about at 1, your magnitude is actually at about 5. So maybe at 5, but however it's about not 1 minus 186 degrees, right? So minus 186 degrees is about at this angle over here, right? This is about 6 degrees. So minus 6 degrees, and this is minus 180 degrees, right? So it's about 5. So this is when your omega is equals to 1. And then at omega is equals to 2. Okay, maybe I should draw it in a wrong shit. Okay, so maybe I should redraw. So maybe it should be, so at frequency equals to minus at 1, okay, at 1. So this is the point. Okay. And then at 2, which is this point over here, maybe I should plot the point first. Okay. At 2, the magnitude is 1. However, it is minus 219 degrees. So this is 180 degrees. 219 is about 39 degrees over here, right? So it should be somewhere at the, so as you can see, this is when it is at minus 2, right? So this omega equals to 1, this omega equals to 2, this omega is equals to infinity. Omega is equals to 0, sorry. Right, so if you were to plot the root locus, right, it always, so in my MATLAB, the graph, right, it comes from here, right, but we didn't show where is it coming from. So it comes from all over here, and then it starts to comes in, which is where the MATLAB shows. Okay, so it starts to comes in, and then it comes in, and then it goes over here, and then it's into this portion. So this is generally the root locus, the graph itself lah. Okay, So as long as you can see omega is equals to 1 is actually at this point, okay? So as you can see, this is pretty much very interesting. Okay, if it's negative, yeah, it's pretty interesting. I don't know how to say. If I have a very small number, let's say I have my omega is equals to my equals to 0.02, right? It's maybe somewhere along this area. You see, you from infinity to 1, you have such a huge long nyquist up to here. You see, so it is pretty interesting, as I say. So yeah. So as you can see, I've shown you how to plot the nyquist plot. Okay. So since I've shown you the how to plot the nyquist plot, let me also show you how about the plotting in the grid. Okay, in the grid. So this is just a preview of plotting the magnitude. Okay, just to let get a feel of the plotting in a graph, so that um, in the future you may actually need it. Okay, so let me plot when omega is equals to 1. So let's say this is, so if I take that in this axis, right, omega is equals to, maybe I should use a larger, omega is equals to 1, omega is equals to 2, omega equals to 3, omega equals to 4, okay, because we are plotting only the positive side, right? And then if you were to plot the magnitude, okay, since you plot that 1 and 2, at frequency equals to 1, the magnitude is 5. So um maybe 2, same thing like this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, so 2 grids. Okay, so if I were to plot, again, as you know that if omega equals to 1, and then if it's negative 186 degrees, which is, if you take a protractor, so a protractor may show that it may be somewhere, some angle lah, okay. Maybe I should use a 2, maybe some angle over here lah, okay. So this is some angle, and then can actually plot at a magnitude of 5, okay. This is, so as you can see, 2 grids is equals to 1, 2 grid is equals to 1, so 5 is equals to 10 grid, right? So when you're plotting all these things, you have to know how many grids. Okay, in this case, let's say maybe 2 grids is equals to, or maybe each of this is 1 cm lah, okay. So so in other words, 1 grid equals to 1 cm, so 2 grid is equals to 2 cm, and then if it's 10 grid, then it will be 10 cm, right? So if you want to plot for 5 magnitude, okay, because how do I say, maybe, yeah, so 1 grid is equals to 1 cm, as I say, right? If it's 2 grid equals to 1 cm, I mean 1, okay, magnitude of 1, okay, then it's 2 cm. If it's, yeah, if it's 2 cm, then if it's 10 grids, okay, so as you can see, 5 to reach 5 you need 10 grids, right? 1, 2, blah 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 to 10, so this 10 grids. So each grid is about 1 cm, right? So therefore, 10 cm to represent the magnitude of 5. So if you want to draw at a, so if when you draw this line, this is the angle line, okay, this is about 6 degrees, and this is minus 180 degrees, so minus 186 degrees ma. So you have to plot about, let's say 10, so this magnitude is actually 10 cm, which is about magnitude, so it's magnitude 5. So you have to, I just want to let you get a feel of it, okay, when plotting these things. Okay, so if you were to do that, eventually you will get that the point over somewhere over there lah, okay? Should be, I don't know lah, just anyhow draw first. Okay? And then if it's omega at 2, okay, so this omega equals to 1, right? And then omega equals to 2, it's minus 219. Okay, minus 219 is some angles. Some angles over here. And at 2, sorry. Never mind. You don't need to follow the 1. Okay, just some magnitudes over here, that's it. Okay, and then if it's some angles, another angle about 219. Okay, this is 219 degrees. And therefore your magnitude is 1, right? So you got 2 cm over here. So this is when omega is equals to 2, this is when omega equals to 1. And if you draw, your root locus is something like that. So this is generally the thing I want to compute. I think in this case it should be negative 1, okay? And then this point should be over here, negative 2. Okay, if you remember the magnitude it comprises of the x and the y axis, right? So definitely this should be at the omega equals to 1, and then I mean this, let's zoom in. So this should be omega equals to 1, and then the real axis, if you remember the magnitude is comprises of the imaginary and the real axis. So if you have a magnitude over here, definitely it corresponds to the imaginary axis when omega is equals to 1. If I didn't, I think I have you understood. Okay. So in other words, so maybe I should. So let's say if I want to plot again. So if I want to plot omega is equals to 1, when omega is equals to 1, the magnitude is 5, right? It should be somewhere about there, okay? Should be somewhere about there. Maybe my angle is wrong, okay? Maybe my angle is wrong. Maybe that's why I say this is a rough sketch only. So it's a little sad how this would turn out to be. So let's say my angle is about 6 degrees. Okay, I just don't want to continue anymore because I'm very tired. Just want to let you know that if you were to plot this angle degree, okay, this point, okay, this magnitude should correspond to this omega equals to 1. Okay, so this magnitude should be 5. Okay, and then the corresponding real value should be some values over here. So this scale is totally wrong lah, okay, but I just want to show you in that manner. But nonetheless, the grid thing still stay the same. I didn't bluff you. So 1 cm is equals to 1 grid. And then if it's 1 grid, so if it's 1 unit is equals to 2 grid. Okay, so 1 unit over here is 2 grids. So therefore 5 unit is equals to 10 grids equals to 10 cm. So you just need to know all this, how to convert these things. And then so this 5 magnitude is actually the 5 unit. Okay, in this case it's 10 cm, so you have to draw 10 cm. So I hope I didn't confuse you anything. It's a lot confusing. Yeah, whatever. So yeah, I'll just leave you to that. I hope I have conveyed that particular good information on that. So this will clear away plotting the root locus. Okay. And therefore, in order to determine the stability of the system, right? This is why we actually need what we're gonna do next. Okay. Okay, we actually need to determine the point. Okay, what is this point over here? Okay. So we have to determine the point that crosses the real axis, that touches the real axis. So we are actually into, so we are actually so-called, we're eligible to do this analysis now. Okay, what what will be the frequency over here that the root locus crosses the root axis? Okay, what will be that? Because typically if you do that, then you can actually determine your gain and phase margin. So I'll see you in the next video. Hope I didn't confuse you or anything. So I'll see you there. Bye bye.